Hello, I'm Michael Holdman, founder and CEO of Prasaga Foundation and the Saga Chain Layer 1 Sharded Blockchain project. I'm making this video as a redo of a demo that we did for the Digital Twin Consortium.org Q2 meeting in Las Vegas in June of 2024. This is a follow-on to the Programmable Smart Assets, Real-World Assets, Digital Twin Future, co-presented by David Bieberman, my co-founder and CTO, and I. The demo video shows a function delivered by our project to business and consumer alike and unachievable to other blockchain models. We have written a new data model for blockchain, which fixes the faults of the current smart contract data model and the UTXO, eUTXO data models, which have limited the crypto industry to a service addressable market of less than 1% of global population of active daily users. 99% of the population is not interested in high-risk speculative assets, hoping to be the next crypto billionaire. The lack of mass adoption of crypto is due to the fact that current data models do not deliver the scale, the security, composability, privacy, or the decentralization, and to boot an architecture that allows the defining of assets as international open standards, which is necessary for global use and acceptance. So what I'm going to do is I'm going to walk through, this is an actual video you can see in our YouTube channel at Prasaga Official. And I'm going to kind of walk through this and talk about each individual stage of this, as well as show the way that we go about and can create now international open standards for any asset in the world. So this demo actually comes from a problem statement that was put out by Bosch Engineering and Business Systems. And what they were asking for is, first of all, can they ever do a auto supply chain on a blockchain? And the answer up to now is very, very limited capabilities. So in essence, no, they cannot deliver what the consumer needs. And this is addressed numerously, heck, just with TradeLens closing down, which was the Merck and IBM efforts in order to create a supply chain and logistics for their customers. So what they asked for was they wanted a reputation score for suppliers. Number two solution they wanted to solve for, a problem they wanted to solve for, is they wanted to understand if they receive a part that does not meet spec, that they were alerted to it. And so that they wouldn't actually put it into the vehicle. And the third thing they wanted to do is they wanted to have full provenance. That means from over here on the dealer side, if you were buying this vehicle, you would also have your account under this column here. And it basically is just your account and what the car was. What they were looking for is full provenance. So they want to be able to go into each individual unit, click on, and have access to every part, every component, every certificate proving each component and part met spec in order to be in the vehicle, every manufacturer, every distributor, every supplier that touched this vehicle from raw material being pulled out of the ground all the way through to not stopping here when the vehicle is transferred to the dealer, but to continue on from when the dealer transfers to the end user, you and I, and then all of the secondary sales, basically until the unit is crushed and not in service anymore. And that's exactly what we provided for them. So I'm going to walk through and kind of talk about these things here. So first of all, suppliers, upstream, manufacturers, dealers, and the end user would also be under this column. So each one of these, Shanghai vendor, Detroit vendor, the manufacturer, dealer A, dealer B, all have their global unique account IDs. We call them ledger object IDs. Ledger object IDs are 256-bit strings of alphanumeric characters assigned by the blockchain, guaranteed to be unique for billions of years. The reason why we can guarantee is because we have a single object state database that we can check against all of the other numbers in there. And if it's a repeat, we'll regenerate one. But chances of that happening on a 256-bit are very, very random. But we do have that cautionary check in there. So every single account has its own unique ID, and then each asset or each object has its own global unique ID as well. Now, these, for instance, spark plugs, these 11,036 spark plugs will always have this ledger ID. And no other spark plugs will ever have that. So that allows us to now understand exactly where each individual item comes from within the supply chain. So let's move to how to order when the manufacturer wants to go in and order spark plugs. It's basically a very simple process. What they do now is they just click on the order button here, and up pops this screen or something. This are just examples. Developers, projects can create any type of UI or the interface that they want to best accommodate their users for their user experience. So you click on order and up pops this screen. This is the LOID that's assigned by the blockchain for these 11,036 parts. And then also populated is all of the descriptions that the actual supplier has put into here. And these are spark plugs, here's the SKU and such. What the manufacturer does is just fills in, okay, I want X amount of these. In this case, a dealer put in 10,000. And then you hit order. And now what happens is those 10,000 spark plugs move from the account owned by the supplier into the account owned by the manufacturer. There is no smart contracts here. So you're not putting a wallet address of the manufacturer into a new smart contract that has an array, that's basically an array, a database, that is a list of accounts that have the rights to something that's in there, but you don't have possession until they actually move out. In this case, because of our third data model, the object state database, we're able to actually, objects can be inside of objects. So your account object is now a container. And in that container is all the objects or assets that you own. So now let's take this down to the standard car model. So now when they want to move the spark plugs down, this ledger object ID is going to, and by the way, the new VIN number of the vehicles is the ledger object ID as well, assigned to that individual vehicle. So that will be a one instance, a non-fungible asset, basically. Those spark plugs, that number now becomes part of this container, the car container. And that car container will now include reference to every part, every component, every certificate, and so forth. Now, you have these beautiful containers with actual reference to everything. Now, this moves forward. When they move this car model over to the dealer, well, then you now have this LOID and the represented cars, however many quantity of those are moved over. Now, let's look at what a containment tree looks like for the dealer. So they have 42 vehicles in here in dealer A of these standard car model types. Let's go over here. So we click on that, and now we see each one of the car model types that is in here. And we can go ahead and click on an asset, and it would actually bring up that container. And that container, which includes every spark plug, every steering wheel, all the manufacturers, all the certificates proving. One point I want to make that's very interesting. The question that was asked in the Bosch engineering for solution number 2 was if they receive a part that does not meet spec, that they're alerted to it. Well, in this object model that we have created, this third data model for blockchain, if the parts that are over under the supplier, if the certificates for, say, the ceramic composition and the metal composition of these spark plugs do not meet the requisite that was put out by this manufacturer, it's not that we would have to alert them that the part doesn't fit. It's actually they would not see it in inventory and available because this model or this rec that they put out, those certificates don't match. So what that means now is one other thing, if they come out with another model that spark plugs do match, then that inventory item would show up for availability to the manufacturer. So now this gives us the ability to understand and limit those recall issues that are there. And just imagine now if you have full provenance from the end user all the way back to everything that ever touched, every transaction that ever happened from cradle to grave, well, then you can be assured that if there is a recall, you can drill down to the exact lot in a production run that item that's faulty came from. So instead of a manufacturer, say, having to recall 500,000 vehicles, now they may only have to recall 500 vehicles. So this is advantages that is not capable within the smart contract platforms. You cannot do composability of 30,000 some odd parts, all of the components, all of the certificates, and all of the entities that touch that unit from cradle to grave. It's absolutely impossible in order to do that, especially across a sharded system. So what we go to next is I will move forward here. And the last piece that I'm going to show you, and I'm going to go to with the call out for the standards um, uh, development. So now we have to add a new part because it's 10,036. They go through, and what you do is you're basically just going to click on the new part button. What that does now, instead of going in and finding a smart contract, copying that smart contract, pasting it into your editor, editing the smart contract, and uploading that smart contract back onto the blockchain and all the code that's already sitting there, you are just referencing a class part. And it's the first time I mentioned that. I'm going to move into that here in a moment. So basically, you click new part and up pops a screen. Now, again, this is just an example of what it could look like. It's up to the designers and such, however they want it to do. But in this new instance that you're going to create for your account, you have a new ledger object ID assigned. And then you fill in exactly what it is. Well, this happens to be wiper blades this time. Here's their SKU on that. Here's the description. Here's the count, the new lot that was built, or the production run that was done and what's going to be put into the supply chain. And any parts used, any certificates that are proving this would all be under here. And then you click create. And by doing that, you now have a new object available to whoever has a requisite or has the certificates in their account that is allowing them to transact anywhere in the globe in that type of transaction. It's now available in a single global marketplace for them to go ahead and purchase that item. So what we've done now is we've created this immutable, auditable system that I have been told by numerous organizations within the actual Digital Twin Consortium, and you can look at digitaltwinconsortium.org and you can see the list of members that are in there. And one of them was actually a pharmaceutical company that stated there's no regulation that the FDA could come out with that they wouldn't be in immediate compliance with. Because what I've shown and what we've created here is an immutable record of everything that ever happened, every transaction to any item that they've ever touched from cradle to grave. And any regulation that would come out, they would have immediate access to all of the data that ever happened to that and could then comply with whatever regulations are there. So that's the demo. Now let me switch to what this does or what this is when I talk about classes and such. So this is the new data model. What this is this is an example. Again, this is an example of an industry class tree for supply chain. One moment. So let's take a look at this. And what we see here is these classes, objects. Any developer that has developed anything, make sure I'm sharing, any developer that has ever developed an app, written an app for a laptop or a device of any kind that has a windowed-based operating system on should be very used to this type of an architecture, this type of an approach to creating apps. It's taken it a little further because you're actually not programming anything anymore. You're just referencing these objects that are on the blockchain. So let's start here, base classes. And these are the call out that we're actually working right now with a few different industry participants and bringing more on through our recruitment process in order to establish these classes and objects and then send proposal into ISO and IETF in order to make these representative of programmable smart assets that we call them as international open standards. So let's start here. SP class account. SP stands for Saga Python. That's our version of Python that we created for the client side here. And SP class object, SP class account. There will only ever have to be one of each of these created globally. Every single object or every single account that's ever created starts from one of these classes. Now let's move down into here. So fungible asset and non-fungible asset. In today's environment, there's a single definition. We all agree a fungible asset is something that can be fractionalized and shared across accounts. We all agree that a non-fungible asset is a singular. There's just one of them. So if we all agree to that, and we all have that understanding, why do we continue to write what a fungible or a non-fungible asset is? Why don't we just have one global instance of code describing that every fungible asset or non-fungible asset in the world will start from? And you reference it and you just define what your asset is. Now, for instance, part is a fungible asset. Well, again, one single global definition for part. Why do we continually look and rewrite or redefine what part is and put it up on a blockchain or in any environments when we can now have an agreed upon one global definition of part, one global instance of code of what a part is, and then everybody that ever wants to create a part and add it to a blockchain and transfer it to different accounts and such and track it with an immutable record now just references class part and then defines what their part is. As I showed you in the video, when you're going through the parts and what you find is, well, my part happens to be wipers. Mine is a spark plugs. It could be a cap on a cosmetic bottle. It could be a component within a new pharmaceutical. It does not matter to us or the blockchain what your part is. We just know that it's a globally accepted definition of a part, and everybody globally will know, yes, this is a part. Same thing with sub-assemblies, assemblies, serialized parts, and so forth. So that's a look at an industrial supply chain approach. Now I'm going to go to one more here, and that is to kind of show exactly what we're talking about. Now let's look here at doing an entertainment. As you notice, class part, or I'm sorry, class object and class account, the same exact classes that were in the other. That does not change. In this case, fungible asset, non-fungible asset. Again, why do I have to repeat or recode what a fungible asset is when I already know what a fungible asset is because I made one for the auto supply? So now we have this global foundation class of a fungible asset. Well, now instead of doing a part, we have a rights certificate. And this is very interesting now, because now we can actually move into a realm or an area where the creator, especially in Web3, The creator now owns all assets. All of their assets, all the IP that they have are now part of the creator's account in their account container. The user now goes through the account container, the content owner, the creator of that IP, and request permission to view a video or have a song or read a document or something. So instead of it going first from the content user, running through the manager, the producer, or whomever it is that is now in the process flow, they become the suppliers to the manufacturer being the content creator or the content owner. They should be both the same. And now when we go to, and a royalty is paid, and this is all automated royalty payments and such like that, by the way, which is a huge issue within entertainment. There's about 2% of all royalty payments are go missing or are something's wrong with them. Well, there's one organization that did $12 billion in royalty payments last year, and that's 240 million in lost revenue to either the artist or to the organization. That's not acceptable. But there's no way to really solve for that in today's Web 2 decentralized database systems. There is here. We now have that immutable record and the automation of the supply chain. As soon as a payment comes into the owner, the supply chain will automatically take that royalty payment and also pay out of that to the manager, the producer, and any businesses that are attached or the suppliers to that content owner. So as you can see, we're creating, again, international open standards. Let's go through each industry, define what the process flow is within an industry, define what those repeatable classes, objects are within an industry, write these out, put together the design docs, and submit this to the ISO and the IETF for programmable smart assets as international open standards on the internet via a blockchain. We are just as our project an extension of the internet, and that's what we expect to be here. So I thank you very much for your time. Please, if you have any questions at all, do not hesitate to reach out to anybody here at the team. And we shall be very happy to help you out. Also, looking for any enterprises, industry, any devs that want to participate also within the Prasaga Foundation in order to help write standards. I appreciate it, and you have an absolutely fantastic day. Thank you.